classes for Python. Okay, so so actually, you can see, in fact, we can write Python on Raspberry Pi. Okay, in fact, because Raspberry Pi is a embedded system based on embedded Linux, so any kind of programming languages can be run on embedded Linux, or Linux system can also run on Raspberry Pi. Okay, so for this chapter 5, we just have a very basic, quick review about what kind of programming languages can be used on Raspberry Pi. So different kind of languages, actually, they have different performance. Okay? When we talk about performance, in fact, we say, how fast the computer, the language, a program using a specific language can run. Okay? So that's the performance issues for a programming language. And also, there are some other performance issues for languages. For example, how big is the program by using a specific language? Because different language actually make different programs. So that means those programs, they may have different size, or they have different running times. So those kind of performance issues, actually, you always want to look at, especially for embedded system like Raspberry Pi. Okay, because Raspberry Pi, this kind of embedded system actually is kind of a resource limited environment. Okay, so for resource limited environment, you want to consider the resources when you write a program more than you do that when you write a program on desktop. Okay, because for desktop, in fact, usually you don't care about the resources, okay? Because usually desktop provides a big amount of resources, like the CPU is more powerful, you have more memory space to use. So comparing to those kind of general purpose computers, Raspberry Pi actually is a resource limited embedded system computer. Okay, so for this kind of computer, when you write your program, the performance is more important. Okay, so that means you want to make sure that you choose a correct algorithm, a correct programming language when you write your program, when you try to solve your problem. Okay, so so that means performance issue is very important for this kind of system, this embedded system. Okay. In fact, for Raspberry Pi, actually, you can make a circuit like this to evaluate your program. Okay, so this kind of circuit actually is very simple circuit. It's a circuit that you can drive an LED. Okay, so you can see for this is an LED, this is an LED, and this is a transistor. Okay, same thing. This is a LED, and this is a feed transistor. It's also a transistor, but they use a different different method to make the transistor. Okay, so so they have different characteristics, but they are all transistors. So the basic performing procedure or performing functionality is the same. Okay. So let's use this NPN transistor as one example. Okay, so this is the transistor. This is the NPN transistor. So you can see it has 3 legs: C, E, and B. Okay, so B is connected through a 2.2 kilo ohms resistor to GPIO 7, and we know this is a output lag. Okay, this output lag actually can output signal to drive the LED. So this is an LED. Okay. LED, you see here, this is the LED. So for LED, in fact, it's a kind of diode, and it's a light emitted diode. And so to make sure that the LED can be on, you have to go through a resistor. So this resistor has a resistance of 120 ohms to 3.3 volts. Okay, so this pin from the GPIO of the Raspberry Pi provides a 3.3 volts voltage. Okay, so this voltage actually will be applied through a 120 ohms resistor onto the LED. Okay, so whenever you have a logic 1 on this leg, if you have a logic 1 on this leg, and E actually is just directly connect to this pin. This pin is the ground pin, okay, in the GPIO of Raspberry Pi. So you have a 3.3 volts pin from GPIO of the Raspberry Pi, and the ground pin from the GPIO of the Raspberry Pi. And this is a PMW output pin. So this PMW output pin actually you can output logic 1. So when you have a logic 1, this logic 1 will make this transistor saturated. Okay, saturated. When the transistor is saturated, from C to E is connected. Okay, so when you have a direct connection from C to E, so you can see this 3.3 volts can flow through the resistor, through the LED, and go to the ground. So that will make a current. This current will light up the LED. Okay. However, if you have a zero, zero in fact will make this transistor open. So that means you don't have any connection between C and E. If you don't have connection between C and E, that means you don't have current. Okay? If you don't have current, then LED will be off. Okay? So that's the working procedure for this kind of circuit. Okay, and in fact, I mean, you have the breadboard, but you don't have the transistor, you don't have LED, you don't have. If you have those kind of components, in fact, you can make a circuit according to this, and then you can test it. Okay, so in fact, in the textbook, they provide the scripts that you can use to either turn on the LED or turn off the LED. Okay, so so this is a very simple circuit for physical computing. That means you can use different. In fact, you can write a Python program to control this. You can write a C++ program to control it, or you can even use scripts. Okay, like the scripts shown in the textbook. If you go to textbook chapter 5, you will see, there is a sequence of scripts that you can use to turn on or off this LED. Okay, so so that's the the way that you can do. Okay, so you can like I've said, if you go to a textbook, you can see the script of code to test it. Okay. So, in fact, like introduced in the textbook, you can use the script language to write program on Raspberry Pi, because Raspberry Pi, we know, is based on Linux, the embedded Linux, and we know Linux actually support script language for programming. Okay, so for script languages, actually there are some options, and you can use Bash. Bash is the the basic script programming language supported by Linux system. And so you can even use Perl. Perl is also a kind of scripting script language, and Python. Python is a kind of scripting language. Okay? In fact, it doesn't need a compiler. We already know that. Python, there is no compiler for Python, but you have to have a interpreter. Okay, so you have to use an interpreter to interpret Python. Okay, and and definitely you can also write JavaScript or Java on Raspberry Pi. Okay, so in fact, when you turn on Raspberry Pi, you will see there is a programming button. I mean menu. So in the programming menu, you can see a lot of options. Okay. So that means, like I've said, Raspberry Pi actually is based on embedded Linux, and we know Linux supports a lot of programming languages. Okay, so that means Raspberry Pi also supports those languages. Okay. Another very powerful language you can use on Raspberry Pi is C and C++. Okay, so and this actually is the major language they use in the textbook. Okay, but we don't use this C and C++, even though it's very powerful. We choose Python as our major programming language for this course. Okay, but anyway, Python, C and C++ actually is not. You're all familiar with this because you learned C++ programming language in your CS1 and CS2. Okay, so okay, so there are. I mean, here we have a lot of introduction description about C++ for this chapter. If you go to the textbook, you will see a lot of examples. Okay, and in fact, you can even download all the C++ programs for this textbook. Okay, so you can download those C++ programs in the textbook, and you can if you have certain components, you can try those programs. Okay, but like I've said, we don't use C++. We don't use C++. C++ doesn't mean that C++ is not useful. Actually, it's more powerful than Python, but it's more difficult when you try to write a program. Okay, Python actually is the most supported programming language, especially for artificial intelligence area. Okay. Nowadays, artificial intelligence is widely supported by a lot of platform. Raspberry Pi actually is also a platform that we can use to do artificial intelligence, and most of artificial intelligence they use Python. Okay, so that's why Python is a very popular programming method nowadays. Okay. Okay, so we just skip this. In fact, there are another option for using Python, and also extend Python to C style functionalities is you can try Thython. Okay, so so Thython actually is a compiler uses your Python program to generate efficient C shared libraries. So that means you can write Python program and you use Thython to compile your Python program into C share libraries, which means in C program, you can call your Python program. And so this is very powerful. That means by using this, actually, you can connect C programming language to your Python programming programs. Okay, so that's a very interesting and useful tool that you can use to, if you have, for example, if you have uh, um, a lot of functions written in Python, and you don't want to rewrite all these functions in your C program, then you can use this to compile your Python program into C shared libraries, and then in your C program you can call this Python functions. Okay. All right. So actually, for this chapter, it's just show you the programming language options that you can have for your Raspberry Pi. And like I've said, Raspberry Pi is based on embedded Linux system, and we know Linux system support a lot of programming languages. So that means Raspberry Pi also support all those programming languages. But like I've said, we will use Python for this class, even though we know there are a lot of programming languages are supported by Raspberry Pi. In fact, C, C++, Java, all those are very powerful programming languages. Okay, but like I've said, nowadays a lot of AI researchers, AI community, they mainly use Python. So that's why I like to choose Python to for the major language for this class. Okay. All right. Any questions? Okay. Um, all right. So if you go to let me see. Okay. Okay. So if you go to eCourses, go to this class webpage and click on module. If you go to week 6, you see project 2 is already there. So if you click project 2, you can see we have a link getting started with SenseHat. Okay, so if you click that, you see in fact there are several steps for this project. You don't want to look at this challenge more ideas. Okay, so project 2 is only for the steps from introduction all the way to challenge putting it all together. Okay, so that's these steps are the only steps needed for project 2. You don't need to look at the last step, the challenge more ideas. Okay, so no, you don't need to worry about this step. Okay, no, this step. Okay. Also, if you go to project 2, you can see there is a PDF file. So you can click on this PDF file, and you can read this step by step. Okay. So let me see. Okay, and it will be due on October 6th. So I give you 1 week for you to work on this project. Okay. So for you, let me show you, give you some demonstration on this. Okay. Okay, so for your Raspberry Pi, remember last time actually for project one, you pull this sense head up off from Raspberry Pi. Actually, this time you're supposed to put it back. Okay, so you have to use this connector and put it back, and also use the screw here to fasten it. Okay, so so that's how you set up this board. Okay, so once you have this set up for Raspberry Pi, actually, I believe whenever you turn on your Raspberry Pi, you will see a page telling you, a warning small window saying you that SSH is on, so you're supposed to change your password or something. So you may want to turn the SSH off. So you go to here, you click this. Let me see. Let's see. All right. So you click on this, the Raspberry Pi icon, and then you go to Preferences, and then click on the Raspberry Pi configuration. Okay. So once you have the configuration on, you see this. There is a window. It seems that it's really. Okay. So anyway, if you go to interface, and there is a SSH, so you can disable it. You see, right now it's enabled. So you can choose disable, and then click OK. So that way you disable the SSH. So then next time when you turn on your Raspberry Pi, you won't see this the warning a small window. Okay. All right. So once you have this, you can do a lot of things on the sense head. Okay, so this is the sense head, and like I've said before, you turn on your Raspberry Pi, you plug the power onto the Raspberry Pi. You want to plug the sense head back to the GPIO through the connector. So this is the connector, and also use the screw you remove last time to fasten the sense head onto the Raspberry Pi board. Okay, so you do this before you plug in the power. Okay, so once you fasten and you plug the sense head onto the Raspberry Pi, you fasten the board, then make sure that everything connect firmly. Then you can plug in the power. Okay, so so that once you plug in the power, you will see the LED matrix actually will be on for the Raspberry Pi. Okay, and so let me show you one program. So to write program for the sense head, you do the same thing like we did last time. So you go to the Raspberry Pi icon, click on it, and you go to programming. Okay, so in the programming, you see there are a lot of programming languages, and choose Python 3 idle. Okay, so click on Python 3 idle, and you will see a window like this. Okay, so in this window, the first menu is File. you can click on File and then click on the first item, which is New File. So once you click on New File, you will have an editor window. So in this editor window, you can type in your program, okay? And the program, actually, you can find the program from the PDF file menu and also from the web page. I gave you the web page for the project, which is getting started with your SenseHead, okay? So you can write program like import and something, okay? But I have the program already, so let me open my program. So if you already have your program, you can use File, Open, okay? So my program is in this folder. So first of all, I want to choose. I want to show you. Let me see. So show message. Okay. So this is the show message program. First of all, you have to import SenseHead. From SenseHead, import SenseHead. Okay. And then first you have to create the SenseHead. Okay. So once you create the SenseHead, this actually they're used to define the colors. Okay. So I define white color for white. In fact, for a color, actually, in computer, we use RGB to represent color. RGB means 3 values. Okay. So 3 values are used to represent the color for a pixel. So the first value is for red, the second value is for green, and the third value is for blue. Okay, so different combination of these 3 values, you will have different color. For example, if all of this, the values for each individual channel, red, RGB, the range is from 0 to 255. Okay, so if for all of these 3 values, they are 255, they are all 255, that means it's the color of white. If all of the 3 values are 0, then the color for that pixel is black. Okay, and if you want to if you want to display red, that means you want to put the first value to 255 and the 2 other values are 0. Okay, so if you want to display a green, that means only the second value is 255. Other 2 values are 0. If you want to display a blue, the last value will be 255. So you can remember the first value is for red, the second value is for green, and the last value is for blue. And if you have 255 for the first 2 values, you will have a yellow color. Okay, so if you want to understand what kind of a value combination you can have, you may do research on RGB color system. Okay, so you can Google to see what kind of combinations can produce what kind of color by searching RGB color system on Google. Okay, so once we set all the values for the color, then we can show the message, okay, by using this sense there dot show message. Okay, so for the show message, first of all, you have to provide the message. This is the message you want to display, and this gives you the text color. Okay, so when you display a message on this matrix, you have the text. You see here, the text color is blue. Okay, and then you have the background color. So the background color here is green. Okay, so you can set up text color by using text underscore color, and also background color by using back underscore color. And also you can set the scroll speed, how fast you want the text message screw. Okay, so let's run this program. Run module. So you can see, you have the preview display on the matrix, and let me slow down the speed. Okay. So you can see now it's slow, right? So the background is blue, and the color for the text is yellow. Okay, so you can set you can choose different color for the display. Okay, so this is for showing message. Let's see. Look at another example. Show text. Okay, so show text is so you can see. Let's run this. You see, you can show text, show different text for a short period, and then you show another text. Okay, so by using this Sans Head, you can see you can show a lot of things. You can show text, you can show a message, you can even show a picture, a very simple picture. This LED matrix actually is 8 by 8. There are totally 64 LEDs. Okay, so you can even display a very simple picture of. So for example, you can show this. You see, this is a figure that you can show by using writing your program. Okay, in fact, this figure is according to this matrix. So you can see, in fact, for each individual pixel, you have in this matrix you have totally 64 values. Okay, each pixel you use a specific color to display it. Okay, so green mean G means green, and B means black. Okay, so you can use different value for each individual item for the matrix to define the color for each individual pixel. And so by doing that, you can draw a very simple pattern on this matrix. Okay. So let's see what else. Okay, so let's run this. You see, this is in this example, you draw a very simple smile face by using by setting individual pixel. You can either set a whole matrix for all of the 64 pixels in the LED matrix, or you can use this set pixel to set one individual individual pixel. Okay, so by setting pixel, this sense dot clear, it means you clear the whole matrix. Okay, and then you can use set individual pixels to set the pixel value, and then you can use flip H or flip V to flip the value. Okay, so So actually, it provides a lot of functions that you can do. Okay, and let's see. Show pixel, show message. For this SenseHead, actually, this SenseHead provides a lot of sensors. It provides a temperature sensor, provides humidity sensor, and also it provides movement sensors. Okay, so that means it can sense your movement when you move this SenseHead. Okay, so let me show you. And also there is a joystick here. Okay, so this is a joystick. By using the joystick, actually you can play a game, even using this SenseHead. Okay, so let me let me show you the joystick program. Okay, so for this joystick program, you can see when I move the joystick actually will detect the direction. I mean, if you push up, then I will show a letter on the matrix, a U, okay, letter of U. And if I push down the joystick, then I will have a letter of D displayed on the matrix. Okay, so let's run this module. Okay, so when I run this module, first of all, the matrix is cleared, right? And then I can push the joystick here. Okay, so if I push up, then you have a U displayed. I push down, you have D displayed, right? So you see here, I push up and down and right and left, right? And push middle. If I just depress the joystick, you got M displayed, okay? Push down, push up, right and left, you see? So that means, so in the future, actually, you can use this joystick to write games. Then you can play on this matrix, okay? So this is the program for joystick. Let's see. Okay, let's use this sensing environment. Okay, so by using this sensing environment, you can sense the temperature, the pressure, the humidity. Okay, it's different. All right, so this is the sense environment program. All right, so let's run this program. You see, it shows temperature like 37 degree. It's pretty warm, right? That's because the sensor actually is on the SenseHead, and this SenseHead actually is very close to the Raspberry Pi board, right? The Raspberry Pi board actually, when we run program on this Raspberry Pi board, the board gets very warm. Okay, so that's why because the temperature sensor is really close to the Raspberry Pi itself. So that means that's why that's a bug, but it's a bug that we cannot avoid, because you cannot avoid to put the temperature sensor very close to the Raspberry Pi, right? So that's a problem. And then you see you have temperature, and then you have, so temperature is 37.7.8 degrees, and then you have pressure. Okay, so this pressure actually is sensed by the pressure sensor. Okay, and then you have humidity. Okay, so this is the humidity in my room. It's 40.9 something. Okay, so you can see by using this SenseHead, you can even sense the environment parameters. Okay. let's look at something else. So joystick, you already saw that. And let's see the movement, okay? So this is the program for movement. So you can see actually same thing. You have to import SenseHead, and then you so the SenseHead actually you have to use the get accelerometer raw function. Okay, so this function actually gets the raw data from the accelerometer on the SenseHead, and then you can get the acceleration. So using the acceleration, actually you can sense the movement. Okay, so let's run this program. Okay, so you can see this is J. If I turn this SenseHead, it sends the direction, and then it corrects the direction of this display. Okay, if I turn this way, and the J is displayed this, and if I turn this way, J display like this. Okay, so whenever it doesn't matter how you turn your SenseHead. Actually, the J always displayed in this direction. Okay, so that's because there is a accelerometer installed on the SenseHead. So in that case, when you move your SenseHead, it can detect your movement. Okay, based on your the detected movement, the letter will be displayed on the the matrix accordingly. Okay, so by turning the display of the J letter, you can see here we have this if statement. So for if statement, actually just depending on your rotation, on your direction movement, so you can rotate your the matrix display. Okay, let's see something else. Okay, show text. Let's look at this ShakeBoard. Okay. So if we run this program, you see when I shake, you see there is a warning showing you are shaking the board. Okay, if I don't shake, it's okay, nothing display. When I shake it, it will display, right? Okay. So you can see actually there are several sensors installed on SenseHead. Then you can write a program to control these sensors, either read data from the sensors, or you can display a message on the matrix. Okay. Okay. So, all right. So that's the demonstration about what you can do for your Okay, so you can. So for project 2, what you can do, you can go to the web page. You see on the first page, introduction. So it tells you what is SenseHead. Okay, and and it tells you what you will learn in this project. Okay, and then you can go to the next page. You see, this is how you can install the SenseHead. So I believe most of you already have the SenseHead installed. So if you don't see SenseHead installed on, so will you so to check whether you have SenseHead installed, you can just run a program. Okay, for example, you can run a program like displaying text. Okay, so in this case, you can click this. You see, you have a very simple program to display a color. So if you write a program like this, and when you run this program, if you don't see any error message, and there is a color displayed on your white display on your matrix, then you have SenseHead installed. Okay. If you see an error said it doesn't find this SenseHead, then you will have to install SenseHead. Okay. To install SenseHead, you go back to the introduction page. Next page. Okay. You type in sudo space apt-get-install SenseHead. Okay, so once you do this, it will install SenseHead for you on your Raspberry Pi. Okay, so actually, I don't know why they always put this hardware connection part in the middle. In fact, you're not supposed to do this when your Raspberry Pi is powered up. Okay, so you want to connect your Raspberry Pi to the SenseHead before you plug in your power cable. Okay, so you don't want to plug in the SenseHead when your Raspberry Pi is powered on. Okay, so turn off your Raspberry Pi, unplug the power cable from your Raspberry Pi, and then you connect your you plug your SenseHead on the Raspberry Pi. Okay, so you already know how to do that. This picture actually shows you how to do that. Okay, you see, first you have to put this connector, and then like that. Okay, and so you can also use online simulator. There is an online simulator. Okay, so you can go to this web page to use the online simulator. But actually, you already have the Raspberry Pi and the SenseHead. You don't need this simulator. Okay, and once you have that, you can display text by using a loop. Okay, so this is the solution. You can see you have this program. Okay, so this program actually, you can, in this case, it display this message. You can also change this message to something else, your name, preview, anything you like. Okay, so you can play with that. Display message, okay. Display text, and then you want to display single character. Okay, so you see this tells you how to use sleep, and for the solution you have the whole program. Okay, so you can write this program in your text. Raspberry Pi Python editor, okay. And then randomness. So you see, actually, this is a very good web page. You can find all the solutions you learn from the project step by step. So this way, actually, it's very easy for you to follow the step by the steps. Okay. And then you can display image. Okay. Also shows you all of the program, and this is the program. How it shows you how can you display a image on Raspberry Pi, on SenseHead actually, and setting orientation. Okay. You see, this actually gives you the method that you can set a specific pixel's color. So this function tells you set pixel row number 2, column number 2 with blue color, okay? And this tells you row number 4, column number 2 pixel with blue color. So you see that? This actually gives you a very small smile face. And then this page actually shows you how to sense the environment. Okay? So you can read temperature, pressure, read temperature, and read humidity. Okay. And also you have this solution for the whole program. So this program actually sense the temperature, sense the pressure, sense the humidity. Okay. And you have all the programs here. Okay. So in fact, you can even copy this program into your editor. So you copy this, and then you paste in your editor. Okay. So you can, for example, in my program, I can paste into the text editor. Okay. And then how to detect movement, and it shows you what is IMU. Okay, so there is a very small IMU installed on the SenseHead. Okay, so you can read this to understand what is an IMU. Okay, so inside of the IMU, you have a gyroscope, accelerometer, and a magnetometer. Okay, so the gyroscope actually is used to detect which way is up. Okay, and accelerometer is used to detect movement, and the magnetometer is used to detect magnetic fields. Okay, so you can see, in fact, this IMU is very useful for like airplane, like shapes. Okay, so it's used to it doesn't tell the exact location, but it tells you your direction, your movements. Okay, so that means in for example, the IMU in a ship, it can tell you the which is what direction. Okay. So you see all the programs are here. Okay. And then next step is showing you how to use joystick. So you can click on this to understand what is a joystick, how to use it, and solution for the joystick program, and solution for trigger functions called with the joystick. Okay, so you see here. And then the next step is for you to put everything together. Okay, so you want to run this program to see how you can, after you put everything together, what it looks like. Okay, and actually you can play, you can have your own idea to do something more. Okay, to make a very interesting, or some practice to either one, to help you learn how to use how to write Python program, or how to use the SenseHead, and two, you can learn a lot of things, this kind of hands-on skills for design new functionalities. Okay, so you can stop here for project 2. Okay, for project 2, You only need to start from introduction all the way to challenge putting it all together. Okay, so that's the only thing you need for project 2. Understand? So again, you have a project 2 for this week. So the due date for project 2 is on October 6th. That's next Tuesday on next week. Okay, so same thing. You want to write a lab report, project report based on what you did for project 2. Okay, so once you finish the project report, you can turn in project report to eCourses. Okay, any questions?
Yeah, you said we only had to do the introduction to what?
From introduction to here, to challenge, putting it all together, all these steps, all the purple steps.
We don't have to do more ideas.
No, you don't need to do the more ideas.
Okay.
Only these purple steps. Okay. Other questions? No? Okay. So before you leave, don't forget type in your full name into chat. That way I can take your attendance. Okay. If you don't, go ahead.
Yeah, this is about the summary I'm supposed to be doing for different things. I started on it. I have the first link or the first source done. I'm about to go to the second source, so I should be done before the end of the week. At first, I thought I had to do a different summary per source. That's why it was taking a little long at first, because I was doing like one source and getting too much information from it.
Oh, okay. But, so you're talking about the LASAM, right?
You said what?
The LASAM? The scholarship?
Yes.
Okay. Okay. Yeah. You can email me. Let me know.
Okay, I'll email you.
You already put everything on Overleaf or not?
Oh, I was working on it on Overleaf.
Okay.
Like going through it, I was doing it directly on that. A better feel of how to do it.
Okay. Okay. Yeah. So just email me. Let me know.
Okay. Thank you.
All right. Any other questions? If no, don't forget type in your full name. And then.
Are you having office hours this week?
I mean, yeah, it's hard to maintain office hour online, but what you can do, you can email me. Email me.
I have emailed you. I'm still waiting on a reply.
Well, when did you email me? I
yesterday.
What's your name?
Gerald.
Let me see. I don't think I got your email yesterday. So you sent email or you? Let me check. Oh, Gerald Wilson. Okay, so I saw email. You sent me email again this.
Yes, because you didn't reply to the first one.
Oh, okay. Oh, the first one I saw it, but I thought it was some some other things. So that's yeah, I remember I saw your email, but yeah, I thought it was some kind of other email. I didn't realize it's from a student. Okay. Okay. So we can set up a time. Then we can discuss on Zoom. If let me try to reply your email. I mean, answer your questions through email. If you think that's not good, then we can set up a time, and then we can discuss on Zoom. Would that be okay to you? Hello?
Yeah, that's fine. That's fine.
Okay. All right. I mean, it's for everyone. If you have some question, just give me an email. If I can answer your email through, I mean, if I can answer your questions through email, I will do that. If I cannot, then we can set up a time, and then we can meet on Zoom, and we can discuss. Okay. So Gerald,
Yes.
yeah, you're still here. Okay, let's do this. So for other people, other students, if you don't have any questions, you can leave, and then I can talk to Jared. All right, so Jared, what's your from your email? You said you're lost and you couldn't even do the first project.
Yeah, because I just got the device yesterday or whatever, and we was emailing all over that, and yeah.
Oh,
So
you live in Dallas, you said, right?
I had to wait to get the device and stuff like that. So I'm just not getting it, and I'm trying to figure out what to do now. And yeah.
Did you watch the video from that week?
Yep, I watched it. You talking about the one with the little orange, the Mandarin?
The orange Mandarin. What?
For the first project?
Uh-huh.
Yeah, you took with the little orange.
What orange? Oh, okay. Oh, the stop motion, right?
Yes.
Yeah. So you can use the push button, right? You have the breadboard and you have the push button, right?
I have the who?
The breadboard.
Yes, the device you gave to my cousin. Yes, I just got it yesterday, so that's why I'm saying I wasn't even able to do anything because I just got it. So that's why I'm saying I
What's your
emailed
question?
you.
You say you lost. It seems that you didn't lost, but you haven't you haven't started, right?
Okay, so I just got this device yesterday, sir, and I emailed you on that, and you knew my situation that I didn't even have the device. Now the project.
So what's your question? You said you just got the device. It's okay. Yeah, you got the device. You can start your project. So you haven't started your project, right?
How do you connect this
You can
again?
start it. You can start your project, and then it's okay. You can still start your work on your project, and once you finish your project, you write your report, and if you can turn in your report through eCourses. If eCourses is closed for that project, you can email your project report to me. It's okay. Don't be frustrated.
All right.
Don't be frustrated.
It's just the fact on how
I
can
know,
I start how can
this
I
is
start
the
it when I don't even know
online,
what the
this kind of
device is?
online scenario is give everyone,
How am
some
I supposed to
problem.
start it when I don't know what this device is? That's why I was asking you what the device was as well.
So for the pack, you got what? You got a bag, right? A bag.
Yes, I just got all of it last night. That's why I'm asking you, what is it? What I need to do? Like, that's what I'm asking. You telling me just go do the project. I'm like, okay, I'll go do the project. There's no problem. But I'm telling you, how do I get with this device you just gave me?
Okay. It seems that you're really upset, right?
No, I'm fine. I'm just trying to get you to understand where I'm coming from.
No, I mean, we are working to solve things, not to be frustrated. Okay. Let me
Oh
show
no,
you.
everything's fine. Everything's cool. That's why I'm asking you, what
It
do I
seems
need
that
to
not.
do?
Yeah. Okay. Let me do this. Okay. Let me show you. I don't know how to. Okay. All right. Let's do this. Okay. So for the in the box, you have this, right? This is
I see getting started with the Sense Hack.
okay. You want to explain to you?
You were trying to show me something, right?
Yeah. So this is the Raspberry Pi. This is the Raspberry Pi board, and on
That's what
top
I'm
of it.
saying. I see your screen. You're sharing your screen right now. I don't see anything. You're sharing your screen.
Oh, okay. Okay. Oh, you didn't see it. I'm sorry about that.